Hello everyone, my name is Saksham Makkar and a very warm welcome to my dearest friends. So today we are going to do a very interesting thing. What's the most interesting thing in the world? It's magic. It just shocks you. Yes, now if I say balancing is also a magic, right? Accepted by all, agreed. So today I am going to tell you a super duper trick from which you can balance anything in the world. Anything. So let us start with our first experiment so that you understand the magic and how to balance things. Then I will tell you the trick behind it, science behind it. So let us start our session. First of all, let us before starting our experiment, you should need a glass and two forks. Forks are available at everyone's house. Yes, right. So, and the third thing is your toothpick. One toothpick is enough, so you need a one toothpick, two forks, and a glass. So let us start our experiment. So, as I told you, keep two forks, one glass, and one toothpick. Now, just try to those two forks, try to stuck them into each other. Try that, you will be able to do that. Now, you had a toothpick. Just try to pin it in the gap between the two forks. And now, the glass. Try to balance it on the glass, right on the glass. Let's see that again. You pin it a toothpick and now you try to balance it on the glass. Now, what you see? Oh my god, it's balanced. Yes, you got it. Now, last time, you just pin it and that gets balanced. How? At the small toothpick, how? Okay, the magic is not over yet. You will be having a matchstick at your homes, right? Take a matchstick. Let's see. Take a matchstick and try to lift the toothpick. What you see? What you see? You did the magic. And now that those two forks are balanced on the tiny toothpick tip. Is it interesting? Yes. So, how is that possible? So, how is that possible? How is that possible that two forks are able to balance on such a small point? How? Okay, so I will be having a notebook. Okay, so in classrooms, like if someone is idle, yeah, so some students try to just revolve their notebooks on their tip of the finger and they're able to revolve it. I'm also not able to revolve it, but what they do, they put their fingertip on a certain point. They know this is all the point. On this point only it will revolve. But how their finger goes only on that point only? How? Now, since this notebook's all the portion is equally distributed, means like I have a pen. Okay, so which means that if I draw sections in it, this section is equal to this section is equal to this section. All these four sections are equal. That is why this is the center of the mass, whole mass. So they are, if you put the finger here, okay, I am putting the finger, will it revolve? No, not at any cost, because it is not the center. So let us understand how in different objects the center changes and whether the every time the center of the object is the center where we can revolve that object or not. So let us understand that. Let us start our center of gravity session, balancing anything in the world. So after seeing this video, you will be able to balance anything, not by your mind but by science. So let's start. So let us not create more curiosity. Let me tell what is the science behind it. How is it possible that two forks were balanced at that tiny tip of the tip of the toothpick? Now, many students, when they are sitting idle in their classrooms, yeah, they try to just revolve a notebook on their tip of their finger. Now, how do they know? Whenever you try to just revolve the notebook, you point at a certain point, you finger at a certain point, yes, then only it revolves. Otherwise, if you put a finger here, it will not revolve, yes, right? Everyone agree? It will not revolve in that case. So, there is a certain point. If you do not keep your finger at that point, the notebook will not be balanced. Okay, छोटा सा experiment बताता हूँ. So I have a rod. Okay, it's a simple rod. So, like if you not have rod also, you can try it with a pencil also. Okay, pencil, pen, all anything. So you had a rod. Now what you do? You try to balance it. Try to balance it. Now you are able to. You are able to balance, right? Now you are able to balance, and sometimes it bends towards left, sometimes it bends towards right. Now since it's a very bigger rod, and if you take a pencil, it will get balanced also. Now why is it bending right or left? Because the mass towards left is more, or towards the right is more. Now like this, it's balancing, right? Yes, it's balancing. So that is how you have to balance. Now let us understand. Okay, now you take a paper. Yes, now if I say that this rod has equal distribution, what is equal distribution? It is equally divided. Here also the same area, here also same area, same area, same area, same area. Yes. Now this is its center of mass. Center of mass means that object center. That object center. And gravity is pulling it from down. Yes, it's pulling. Here also pulling. It's pulling here also. Yes, the force of gravitation is pulling. Now 4 times pulling here, 4 times pulling here also. Can't we say that the force is pulled in the same quantity as of left, as of right? So can't we say this is our center of gravitation? In every object it is. Like if you see a circle, its center is a center of mass also and center of gravitation also. Now I took the example of the rod. Now I took the rod. Now suppose I attached a 5 kg something, any material, 5 kg iron to it. Okay, it's 5. Now this was the point I was pointing earlier. Okay, this was the point, the center of mass. And what happened, that when I put the finger here, it's going towards the left. Okay, it's going towards the left. It's going towards the left because a 5 kg material is attached to it. And what do we need to do? Now what you will do, you will say, yes, okay. You had sit on seesaw. Yes, if this is you 5 kg. Okay, now what happens? Your younger brother is also there. You say, just go and sit there. Now you will be balanced. You say your 5 kg younger brother also, that's it there. He's also 5 kg. You are also 5 kg. So they get balanced. Okay, but I am not asking you to get balanced, but I am asking you that there is no younger brother. Now try to balance it. How will you do it? You will change your point. Yes, you got it. You will change that point. Now, if you change that point at a certain point, the mass here would be equal to mass here. And this point would be known as your center of gravity. Why center of gravity? See, if here this mass is equal to this mass. Okay, now force is what? Gravitation is the force. Force is equal to force, and this is m into a. This is also m into a. Acceleration would be a gravitational force only. So it will 10 on both sides. This is equal, and mass, if the mass is equal, their force is equal. Simple. That is what you need to understand. Now if I took a glass, I did an experiment. Okay, I took a glass and I balanced two forks on it. What does that mean? It does not mean this is only the figure. You need to complete the figure. As you will make a figure out of it, you will see that the center of gravitation is right below that toothpick. Is right below that toothpick. So you need to understand that, and then you will be able to balance anything. Okay, what is the center? Okay, I say this cylinder is equal distributed. What is its center of gravitation? The center would be a center of gravitation. Yes, right. So that is how you need to understand how to take out the center of gravitation. And once you took out the center of gravitation, you are the magician. So you will be able to balance anything. Just you need to understand the science behind it. So thank you for watching. I tried my best to explain you how to balance.